This week we start looking at design, and we're transitioning away from requirements. Now, this is not a class that's going to teach you everything you want to know about design. We want to give you a general idea about what we want to capture in design, and most importantly, what we really are trying to do is equate what we did in requirements and continuing that into design to see that we have that transition, that crossover. And then we're going to take the design and then toss it over into testing and a little bit of some implementation decisions. So this is, again, not supposed to teach you everything there is about design, but I want to give you some high-level overviews to talk about how we capture designs and how we might be carrying over some of what we did in the requirements into this design phase. And that's really going to be the core part of what we're going to get. That's going to be the focus of what we're going to be talking about. So to that end, let's talk about requirements versus design. What's the goals? What do we do differently in each of these phases of our project? So in requirements, we're focusing on what the stakeholders need. We want to say, what's your problem? What are we trying to solve? We do a certain amount of what I'll call solutioning. I don't think that's a real word, but it's a nice word that appears a lot in engineering contexts. So we do a lot of solutioning to figure out how can we solve your problem? What are the acceptable approaches to solving this problem and the limitations that might, narrow down acceptable approaches to the problem. And then from there, we want to talk about what are the different ways we can really go about and make that happen. We're not getting all the way down to the final bits of everything. We're not talking about the exact pieces. That's what design's job is. That's going to be basically the requirements part is how do I merge people and technology into acceptable solutions? What are the things that people want? So as an example, a requirement could be I need to build an iPhone app. Okay, so wait a minute. iPhone, that's a design decision, isn't it? By iPhone as opposed to Android, as opposed to HTML5 that you access to the browser. Well, yeah, it is a design decision, but it could be a limitation imposed by the customer. They could say, hey, I've always wanted an iPhone app because I think iPhones are cool, and I want my company to have an iPhone app because there's prestige to that. So it's really a design decision that's imposed requirements. So what do we mean by design decisions? What's unique about design? Well, design is about coming up with that specific plan within that app. When I'm doing design, I want to be modeling out the approach of how do I solve the problem and start to be able to lay it out in the way I'm going to build it. When I say an iPhone app, it doesn't give me any structure to how that app's going to be. It doesn't tell me what screens are necessarily going to be there. I might start a little bit of that. It certainly doesn't tell me where I'm storing data, where I'm making calls to my internet server-side things. It doesn't tell me all of the details of what's going on. And so design's job is to start to define those details and to gain consensus about the approach. I don't build a design per se so much as I socialize a design in the software world. It's not like where I have to come up with blueprints that somebody else is going to manufacture. In software, you're manufacturing the end product at the same time. So really the purpose of design is a little bit different. So when people use the analogy is design's like building a house. No, it's really not. Because when I'm building a house, I'm definitely not building the house when I put it on paper. The architect's job is not to build the house. The architect's job is not really even to talk about how the house is built. They're talking about the general structure, the general approach as a communication tool. And that's what we're doing in design, in software engineering and information technology, is we're trying to get to the point of being able to describe what we're going to be building. So the goals of our design is to refine the solution. So we did the requirements and we have an understanding of what's going to be out there. So let's refine that understanding. Let's look at those limitations and see what questions come up. Part of what design is to kind of feedback, do I really understand what's going on here? Do I really understand what the need, what the desire is? And then I want to look for any gaps or gotchas in that. So if somebody says I need an iPhone app, and then you realize that the target market is people who don't own iPhones, in general, you find out that there's a gap, or the iPhone, maybe part of what it needs to do is have, interaction with Google Maps, and not everybody has Google Maps in their iPhone. I'm just using that as an example. Then that's a gotcha. That's something you have to consider. Well, maybe you have to do something that's always on an iPhone. The Apple Maps, or I don't actually use an iPhone, so I don't know the details. So you got me there. So that's one of the goals. The other goal is communication. We want to have some vehicle, some documentation, some communication, some pictures, something to help us share the ideas. And more importantly, when we're sharing the ideas, to negotiate the approach to those ideas. There's many stakeholders just on the development team, people who are writing the code themselves. So let's talk about what are the ways we want to build into the design, and let's get feedback from other teams. Because we might not be the only people. There may be multiple development teams, there might be networking teams, there might be security teams. You don't want to go and build something and then figure out later on it's not the right thing. Certainly that's why we draw blueprints. That's why we, in building design, that's why we do it, is to communicate the ideas. So that part of it is exactly what we're going to do. And so we're going to spend a lot of the time trying to improve our understanding and improve our approach and communicate our approach to other teams. Now, past that, we're going to get into some flexible options. Designs are going to be coming very differently based off the team, based off the people, based off the approach. So some teams really don't need to be super formal in design. When we talk about blueprints, they're very formal ways of drawing stuff up. Not everybody does that. Not everybody gets you exact plans, exact measurements. Sometimes you have pictures that are maybe not to scale. Or maybe sometimes you're just drawing on a napkin and saying, okay, that was good lunch. Let's draw this up real quick and then move from there. It depends on the team, it depends on the need, it depends on the formality. So the amount of documentation when you come to a software project is going to vary based off of where you end up choosing to work. Some are extremely formal. Some have many, many, many pages of documentation. Some have very formal reviews and sit-downs, and others are like, let's sketch it out on the whiteboard and go from there. Most fall somewhere in between there. There's going to be some level of formality, but there's also going to be some level of make it up as you go. And so an ad hoc design really is mostly where people just bring ideas to the table. We know we need to collaborate. We know we need to set a direction for when everybody's going to build the code. And what we really want to do is say, okay, my team's building the iPhone app, your team's building the server side for the iPhone app. How do we communicate back and forth? Are we doing web services? Are they going to be REST services? Are we going to do JSON? Are we going to do, what calls are we going to have? How are we going to send data back and forth? What's going to be the inputs? What's going to be the outputs? What's being done on the server side? What's going to be done on the phone side? If you're talking about different applications, you can talk about web applications. What is done in the database tier? What's going to be done in the server tier? What's going to be done on the browser? If you're talking about back-end systems, you're going to be saying what is being done in which one of the batch jobs. All those different things, depending on what your project's going to bring forth, is going to have different types of decisions to be made, and that's the basic stuff. This is stuff that has to be decided by all designs. But in an ad hoc team, that's a temporary document. We're just kind of throwing stuff together, and really the code is defining what our system does. We don't need formal documentation that lives forever because our source code is going to be that documentation. You want to understand our system, go read the source code. We make great source code and it's super readable. This is one approach to solving that because paperwork is expensive, and to do all that is expensive to do the upkeep. I don't want to do all that sort of work. Where the flip side of that is the formal design, where I have a very clear approach and a very clear plan to tell me exactly what I'm building. The goal of that is to have less, decisions to be made later on, and less things that can screw us up in the future. The thing about ad hoc plans is, I thought you meant this. No, I thought, did anybody take a picture of that whiteboard? I don't know. As opposed to a formal design document, is something you can sit down, review, approve. You can share it with your test team. You can share it with your project sponsors. You can share it with security team. There's all sorts of good, you can go back and update it. You can go see it for future projects. There's all sorts of good formal reasons. We want to cover all the solution that we need to make sure we're getting done there. We need to make sure that we've really, we're not leaving anything to chance. We know exactly where it's going to go. And we get the ideas out of the developers' heads and into everybody else. Now, the reasons why we would do this is variable. It's not to say that one of these is right, one of these is the other. You might be sitting there saying, that's too formal. You might say, that's too crazy. There is good reasons for all of these. And so how you choose the design approach is going to be up to your team. Now, what we're going to talk about here for the rest of the sessions is different mechanisms by which we can go through and take that design approach. We're going to get off the high levels of formality. What we're going to be asking for in the assignment, as you go and look at the assignment, and they'll be described in different contexts from this, is really kind of some high-level pictures. This class is covering too much to do a big formal design. So that conversation, the conversation we've had here is giving you that setup for where are things going to go. What we're going to ask you to do, and we're going to spend most of our time on now, is we're going to look at structured design. There's going to be a series of these little micro lectures that's going to tell you about aspects of creating data flow diagrams, which is what you're going to be asked in one path to do inside of this. And this works really well. It uses functional breakdown that aligns well with the code and logic. It gives you some nice efficient code and works well within structured, procedural coding languages, things like C, things that were pre-existing to object-oriented, so C, early Ada, Pascal, all those sorts of things. Now, most modern languages use what's called object-oriented approaches, where we look at data and functionality merged together, and hopefully you've seen some of this by now. Structured design, maybe, maybe not. Object-oriented, hopefully, I almost guarantee you should have seen something by now on this. And the idea is to merge the models of the real world using actors and the real processes. And we're going to get data and group it with functionality and hopefully have the system be more maintainable, extensible over time because all this modern language support. And this is just basically the evolution of where software has gone. It's a much better way of modeling and putting software together. So given this introduction, we're moving from requirements and design, and now we're going to learn about the details of putting these things together. And you're going to be asked to do several of these. So you don't necessarily need to watch absolutely every one of these micro lectures, but I think they're valuable. I think it's worth at least perusing one time and spending a couple hours this week. Some of them you might come back to do the homework this week. Some of them you might not. That's perfectly okay too. But take your shots, take a look at it, and we will go from there.